Continuing with surface area of solids, we did a rectangular prism. Let's do a very special type of rectangular prism. So just like a square is a very special type of rectangle, a cube is a very special type of rectangular prism. All right, so I did the best cube I could. So this is a cube, and a cube is a special type of rectangular prism, because squares are special types of rectangles. So if I wanted to find the, let's say that this was 3 centimeters by 3 centimeters by 3 centimeters. By the way, since it's a cube and I told you it's a cube, I only have to tell you one of these dimensions and you should be able to figure out that they're all the same dimension. Okay, so just because I didn't tell you that the depth was 3, you should know that the depth is 3 if I tell you that it's a cube and that the front side is 3. And then what should the height be? You guessed it, 3 as well. So 3 centimeters by 3 centimeters by 3 centimeters. And just because I picked 3 doesn't mean I couldn't pick another number. Let's say that I picked, let's say I picked 2. So if it was 2 centimeters high and it's cube, then it's 2 centimeters long, 2 centimeters deep. If the height was 4, then it'd be 4, 4, and 4. Okay, so you get the idea. All right, so how do you find the surface area of the entire outside of a cube? Okay, well, let's write its net. Okay, so let's do the net. So the net is actually pretty quick to do for a cube because each part of those component 2D shapes that make up the 3D shape are all squares. So we know that this is a square, this front. The side is also going to be a square. The bottom is going to be a square. The left-hand side is going to be a square, although I need a little bit of room to actually write the square. And then the top is going to be a square as well. And then if I had more space, which I'll make more space here, then the back side would also be a square. Now again, your net doesn't need to look like that. Maybe you put this one down here. That's fine. As long as there's 1, 2, 3, 4, 5, 6 squares and they're all connected, you have done yourself a net. Okay, and these are 2 by 2 by 2s. So, so what we've got is like this, like that, and then I go like this, like that, like that. I have just created 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I have created 24 squares. And what kind of squares? Since they are centimeters, in this case, they are square centimeters. All right. But I don't always want to count these up. There's 24, and that's not too bad to count. But what if there were like 1,000? You don't want to do that. So what is the surface area formula for a cube? We did the surface area formula for a rectangular prism in general, which you could also use for this. But because this is a cube, let's take advantage of that fact to simplify the formula. Okay, so what do we do here? Let's call this the length, let's call this the height, and let's call this the width. Again, you could use different letters, but I'm going to use these because it's sort of traditional and in the book, so I'll go that way. So if we have the height as 2, the length as 2, the width as 2, and we want to add up all these sides to get to 24 without actually having to count all of them, SA, again, is surface area. It's just an abbreviation. So what I would do is, let's notice what one box is. This one box has 4. This box has 4. Wait, this box has 4. They all have 4. Each of these, I'm sorry, squares. Each of these big squares have 4 little squares in them. That's interesting. So what I could do is, instead of counting up 24, a quick way of counting is multiplying. So if I know that there's 1, 2, 3, 4, 1, 2, 3, 4 little squares and one big square, and there are 1, 2, 3, 4, 5, 6 big squares, then I could do 6 times 4, and that equals 24. Look at that. So what you can do is, to make this surface area formula shorter or more concise, is what you can do is you can take the surface area of just, or the area of just one of the squares, and then multiplying it by 6, because there's 6 faces. So this 6 is great. Now the 4 is particular to this case, but let's say instead of saying length, instead of saying height, instead of saying width, which we're all 2 because it's a cube, why don't I just call it S for side? Because each side, the length times width and the length and the width and the height are all the same number. So why don't we, for any cube, so why don't we just generalize it just to say S? So if I call this length S, this has to be the same length, because every variable that is the same here needs to represent the same quantity. So S times S will give us this square, which is S squared. So this area of this particular square, the front square, is S squared. But wait a second, the height over here is also S. So S times S is, oh, S squared again. Oh, and the width, the depth, and the length is also S over here. So this is S squared. All of these faces are going to be S squared because they are squares, and there's 6 of them. So instead of saying 4, which it was in this specific case, I can generalize. And I know that any cube is going to have a surface area of whatever one of the squares is, and S I'm using for side. But you don't have to use S. Again, you can use whatever letter you want. If you want to use just anything, how about like A? You could use any letter. Then each of these lengths for all of these would be A. And then these would be A squares in here. That's fine. It doesn't have to be an S. I'm not even a fan of an S because S's look like 5s. You could call it A if you want to. 6 times A squared. That's fine too. You can use any letter you want. We are not memorizing formulas here. We are trying to understand how these formulas are created, and then you can write them however you want as long as they're equivalent and showing the same concept. So this is a quick way to come up with the surface area, meaning all of the outer areas of a cube added up. That's the quick formula to use if you have a very special type of rectangular prism, which we call a cube. Okay, so that's how to do cubes. We've done rectangular prisms. In the next video, we're going to move on to 3D shapes that have circles in them.